So whereas in diploma second year we have the chapter of Laplace transforms. So here an inverse Laplace transforms. So here let me check the first one, Laplace transform. So actually what is the Laplace transform formula? The formulas let me see here. L of e power at is 1 by s minus a, whereas in a place we have 2, so in place of a you may substitute 2 here. Similarly, the remaining formulas are L of sin at, a by s square plus a square. In place of a we have 3. L of cos 4t, that means L of cos at, s by s square plus e. Actually it is here hyperbolic, then hyperbolic will come here, minus will take place. Otherwise if it is not hyperbolic, then here plus will come. And L of constant is constant by s, and L of t power n formula n factorial by s power n plus 1 form. Here let me check a problem. L of sin 3t cos 2t. So L of sin 3t, here we have the individuals for trigonometric multiplies and submultiples, but here we haven't have the formula that sin 3t into cos 2t. So in this one we have to write a formula for this. So which formula? It is in the form of transformations by simply multiplying divided with 2. So 2 sin 3t cos 2t. So 2 may write outside of the Laplace. So 1 by 2 L of 2 sin 3t cos 2t. So now this is in the form of 2 sin a cos b. 2 sin a cos b formula, sin of a plus b plus sin of a minus b. Sin of a plus b plus sin of a minus b. 1 by 2 L of sin phi t plus L of sin t. Now let me take the individuals with respect of the property of Laplace transforms. So 1 by 2 L of sin phi t plus L of sin t. So 1 by 2. Now we have the formula L of sin at formula. Just now we seen it here. L of sin at is a by s square plus a square. A by s square plus a square. In place of a we have phi. Same one. In place of a we have 1. So 1 by s square plus 1 square. So this is the problem with respect of by using the transformation formulas from the trigonometric. Now the first shifting theorem. So here we have the another form in first shifting theorem in Laplace transform. So the problem should be in the manner L of e power 2t sin h of 3t. So here let we take the first one. We don't have the formula for this, so let we take the sin h 3t as f of t. So taking Laplace transform on both sides, L of f of t is equals to L of sin h 3t. L of f of t is nothing but f bar of s by the formula. So L of f of t equals to f bar of s is equals to L of sin e hyperbolic. So a by s square minus a square. Hyperbolic will come, then the minus will take place. A by s square minus a square. Now we have the formula for shifting term is what? L of e power at f of t is equals to f bar of s minus a. That means in place of s we have to write. So already this is what f bar of s. In place of s we have to write s minus whatever the e power is there we have to write there. So the problem L of e power 2t sin h 3t. What is f bar of s actually? F bar of s is this one, 3 by s square minus 3 square. In place of s we have to write s minus a. S minus, in place of a we have 2. So to substitute here. So this is by using first shifting theorem. Okay. Now here we have the another property, change of scale property. So the formula we know that L of f of t equals to f bar of s, then L of f of at equals to 1 by a into f bar of s by a. By simply writing in place of f of t, f of at will be there. We have to write 1 by a bar of s by a. Let me check a problem for this. So a problem, if L of f of t is equals to, so here L of f of t equals to s plus 1 by s plus 2, then find L of 3t. L of f of t equals to f bar of s is this one, then find L of f of 3t. So let me check from the given one. This is known, we know that L of f of t is equals to f bar of s. This one is equals to, now what he asked, L of f of 3t. L of f of 3t is 1 by 3 f bar of s by 3. So 1 by 3, what is f bar of s? Already we have from the given s plus 1 by s plus 2. Just by writing in place of s as s by 3 plus 1 by s by 3 plus 2. By simplifying this one, we will get the answer. Next one, multiplication of t power n, very important in the Laplace transforms. Okay, here the formula is, if L of f of t equals to a bar of s, we know that, then L of t power n f of t equals to minus 1 power n into d power n by ds power n into a bar of s. Okay, let me check a problem. Here the derivative will comes place by differentiating a bar of s. Okay, let me see the problem. Yes, find t into sin 3t. We don't have the formula with the multiplication between t and sin 3t. We have only sin L of sin 3t formula and L of t power n formula. But if the both of in multiplication, here the multiplication of t power n formula will takes place. Okay, you have to observe that. Next, here let we take f of t is sin 3t. L of taking Laplace transform on both sides. L of f of t equals to L of sin 3t. Formula a by a square plus a square. So we know that L of f of t equals to what? A bar of s. So we got a bar of s. Now the multiplication of t power n formula from the given problem, L of t sin 3t is equals to minus 1 power n d power n by ds power n f bar of s. What is a bar of s? 3 by s square plus 3 square. Now 3 minus d by ds of 3 by a square plus 9, 3 right outside, derivative of 1 by s square plus 9. Now this is in the form of d by dx of 1 by x form. D by dx of 1 by x is minus 1 by x square. This is not a single term. So by chain rule, we have to differentiate this one. S square derivative is 2s plus constant derivative is 0. In this way, we will get the multiplication of t power n problems. Next one, division by t. So if L of f of t equals to a bar of s, we know that, then L of f of t by t is equals to integration of s to infinity a bar of s. If you will get the in problem, if there is any division by t, then you have to know that, so okay, this can be solvable with respect of division by t formula. If the divide by t is will be there, you have to identify that yes, this is a division by t formula we have to apply. Let f of t equals to sin t, taking Laplace transforms, we know that after this one, yes, L of f of t equals to L of sin t, a by a square plus a square, that is called a bar of s. So division by t, the problem we have, L of sin t by t is equals to the formula we have, integration of s to infinity f bar of s ds. What is f bar of s? 1 by s square plus 1. Clear? Formula, division by t formula, integration of s to infinity f bar of s ds. What is f bar of s? 1 by a square plus 1 square. Substitute here. Now this is in the form of integration of 1 by x square plus a square formula. 1 by a tan inverse of x by a is the formula for this. So 1 by a tan inverse of x, in place of x we have s by a. So the limit values are s to infinity. Tan inverse s to infinity, upper limit minus of lower limit. So when tan will becomes infinitive, tan 90, that is tan pi by 2. Tan inverse s, tan inverse tan get cancelled, pi by 2 minus tan inverse s. So 90 minus tan inverse s can be written as cot inverse yes. Now we have a problem, another different problem in, except these multiplication of division by t, other than we have in Laplace transform, one of the important formula. If L of f of t equals to f bar of s, comma, then L of integration of 0 to t, here t will takes place. You have to identify if the given in the given problem, if you get t, then you have to take out the formula from your brain, that is integration of 0 to f of u d equals to 1 by s f bar of s. Let me see a problem. L of integration of 0 to t e power minus t cos t. Yes, you have to identify that if the 0 to t will be there, yes, it is a problem with respect of this formula. Let we can take f of t equals to cos t, taking Laplace transform, L of cos a t s by a square plus a square. Let we can take it is capital F bar of s. because some more f bar of s will come. So let we can take here capital F bar of s. Now let we can take individually. First of all, we have done this one, e power minus t cos t, first shifting theorem. In place of s, substitute s plus minus, so s minus of minus 1, s plus 1 by s minus of minus 1, s plus 1 whole square plus 1 square, s plus 1 by s square plus 2s, simplification. Now the total problem, L of integration of 0 to e power minus t cos t. You may take this one as f bar of s, final one. So the total problem is this one is equals to the formula 1 by s f bar of s. So 1 by s. So what is last f bar of s is this one. But by first shifting theorem, we have to write capital F bar of s plus 1 by f bar of s plus 1 and here. So let we can substitute here. Clear? One by one step. F of t equals to cos t, taking Laplace transform. After that e power minus t cos t, L of. So we got this one. After that total problem. The total problem equals to the formula 1 by s f bar of s. So 1 by s f bar of s, the last one, s plus 1 by s square plus 2 plus 2, this one. So we completed the Laplace transforms. So and you have the task for Laplace transform and as well as inverse Laplace transform. In the next class I will tell you about the inverse Laplace transform formulas too and the problems too. Okay, thank you.